right, we're going to be talking about transformations and then domain and range of quadratics. So remember, so quadratics are your x squares, and it's your parabolas. So just like before, when you think of domain and range, you should still think of Doc's ray. That helps us because the domain are our x values, and our range are our y values. Okay, so Doc's ray. So let's go ahead here. And let's say I have let's go ahead and draw a parabola. I know that's not beautiful, but it is what it is. All right, they're also so you need to be able to find your vertex, which the vertex is here. And right, so this is smiling. So, I mean, not smiling, excuse me. This is frowning. So this would be a minimum. So we know that at least, right? Geez, what am I talking about? No, it's a maximum. Frowning, max is the frowner. So this is going to be a maximum. All right, so when you're thinking of domain and range, so we're going to put domain, range. So the domain is x for all x. The range is going to be y for all y. It's just a fancy notation. And you got to think for domain, your domain are your x values. So this is your x-axis here. Now, the parabola is a U-shaped graph. It gets gradually and gradually fatter or wider. Therefore, as these are going out, the arrows, they are going to keep going wider, 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 wider. So for every single quadratic that we're going to be doing in this class, the domain is going to be all real numbers. So you can put your double R, or you could actually say all real numbers. The reason is, once again, those arrows are just going to get wider and wider and wider, and they're going to encompass all of the x values. The range is a whole nother story, because if you look at the range, it's here, and it's all these values. So it is going to eventually get fatter this way. But we're never going to hit any of these values up here. So we have to figure out what that maximum, what that vertical point is. And if I look on there, it's the point 1, 1, 2, 3, 4. Okay. So this is the range. So I want to take the y value, which is 4, and I'm going to go ahead and put it down here. So 4. Now I got to determine if my y values are going to get less than 4 or greater than 4. As you look, they are going down in value. Therefore, they are becoming less. So you would say y for all y less than or equal to 4. Let's do another one. So let's say we go like that. Okay. First thing we do, let's go ahead and x for all x, y for all y, so our domain and our range. Our x's, once again, they're going to keep getting fatter and fatter and fatter, and we know for all quadratics that it's always going to be all real numbers. This time I'm just going to write it out. For y, I find the vertex, which this time it's smiling, so it should be a minimum. And it looks like it's at the point -2, 1, 2, 3, down 4, so -4. This is the range, so I want the y value. So I go ahead and plug in -4. And then this time, all of my values are getting greater from this point. They're all going up in value. So since they're all going up in value, they are greater than or equal to. Last one, let's do, wait, that was similar to the one over there, isn't it? Sorry. Let's do this one over here. Like iffy. Let's go down here. Okay, that looks good. All right, so I would say x for all x, y for all y. Once again, we know that the x is going to be all real numbers. I got lazy, so I just did my double R. For my y, I find my vertex. Let's just pretend that it's more over that way. So it'd be -2, -1, that's that point. I take the y value, which is -1, and then all of my numbers are getting smaller. All of my y values are getting smaller, so less than or equal to. Okay, that's domain and range. Let's talk about transformations. The parent function for a quadratic is y equals x squared. Okay, pretty much what that's saying is your a is 1, your b is 0, your c is 0. If you break down the y equals ax squared plus bx plus c, I talked about this in class, but your c, your constant, is your y-intercept. And that's similar to y equals mx plus b, right? So that plus b is just a plus number. That was your y-intercept for linear equations. But for here, our plus c, our constant, our number without a variable, is our y-intercept. In terms of what happens, we're not going to be worrying about anything with the b for now. But for a couple things happen. So we talked about if a is negative, let's go purple. So if a is negative, remember that's a max, that's a maximum point, and remember max is always frowning. If a is positive, that's a minimum point, and that's a mini, she's always smiling. We've already talked about that. However, in terms of a, if it is a whole, or if it's not a fraction, if it's an integer that is not a fraction, or just an integer in general. So if it's 4, how do I say this? Okay, if it's just an integer, it's going to become narrower, which AKA means skinnier. If it's a fraction, and we're just talking about the a right now, if it's a fraction, it's going to become wider, AKA fatter. All right, so let's look over here. Describe the transformation, and let's get some room. Describe the transformation from our parent function, which is y equals x squared, and y equals -6. So first of all, our parent function is positive. Over here, we've got a negative. So immediately we know it's going to be our parabola will be turned, or let's just say pointed downwards. And we can even draw the little sad face. Now, we also have to take care of the 6. So if it's an integer, it's going to become narrower. So you would say becomes narrower. And that's really as specific as I need you to get. I don't need you to say by a scale factor of 6 or anything like that or whatever. Just go ahead and say it becomes narrower. For example number 2. Okay, so y equals x squared. Let's first make sure our a is positive, so it's still going to be upwards. They took a fraction for our a, so remember if it's a fraction, it becomes wider. Okay, so the parabola, and this, I guess let's get grammatically correct, that is a capital T. The parabola will become wider. And now we got to think about this, what this +1 does. So this is technically +0. So I told you the constant at the end affects the y-intercept. So if the x-intercept or the y-intercept for the first one is +0 and the second one is +1, we just move the entire thing up 1 unit. So the parabola will become wider and move upwards. Move, not moves. And move upwards 1 unit. All right, here's your practice problems. For 1, 2, and 3, you do need to graph them. We still need to work on graphing. So you need to graph each one and then give the domain and range. And then from 4 or 5, you're just giving me a sentence or two explaining what the transformation happened.